Apparently, Justine kicks Alita, and you can find all about it in the what you call it in the when you read it. Actually, I mixed it up. It's Alita kicks Justine, and she kicks her in the midsection, right in the stomach, sends her flying across the roof with a velocity VJ, measured in meters per second. Obviously, it's VJ because it's the velocity of Justine. Right into an odd-looking wall. Justine has a mass MJ. To her surprise and relief, she discovers that the odd-looking wall is a crate. The odd-looking crate, that's on the wall, is actually some kind of spring mechanism used for launching things. The spring has a spring constant of K and of negligible mass. Assuming that the surface is frictionless, calculate the maximum compression of the spring after the collision, and suppose that there is a constant force of kinetic friction that acts between the block and the surface with mu k. If the speed of the Justine at the moment it collides with the spring is Vj, what is the maximum compression of the spring? All right, so here's the two parts. So we got the girls again, and they're on top of the roof. And this time we got someone going, hiya! And then the other person goes, ugh. Ugh. Because she got kicked in the stomach, right? In the midsection. So she's flying back with a velocity. She's flying back with a velocity VJ. And she hits this spring. I'm just going to draw it as a spring. It looked like a crate, but, I don't know. The spring is attached to the roof or something, right? Which is kind of nice because, if you're going to land on something, you want to land on something that's kind of springy, right? That's why they have, these little spongy floors at gymnastic studios, right? Because when you land on something, you kind of want to have some give to it. So instead of hitting the wall with a thud, she lands into this thing and it has a little stuff. So here's my question for you. I'll tell you what the spring constant is. It's K. Now my question for you was, how far does the thing go back? So delta x equals what? That's what the question is. How far does the spring compress when she, crashes in there? The second part of it, part B, let's do that in orange or something like that, is there's going to be, and this is without friction. The first part was without friction. The second part is with friction. If there's friction of mu, then, it's mu k. Then my question for you is, what is the new delta x? And I got a question. Do you think delta x is going to be bigger or smaller than the first scenario? The first scenario was without friction.
Probably going to be smaller.
It's probably going to be smaller because it's a constant friction force pushing on this thing as she crashes in there. And so that friction force will probably, help the spring out a little bit and it won't have to compress as much. Does that kind of make sense? I guess if you were looking at it energy-wise, going into this, she has all kinds of kinetic energy. And then compressing the spring, it compresses to spring energy, right? Mm-hmm. And if there's no force of friction, that's all you have to worry about. But if there is a force of friction, what you also have to worry about is this additional work that is done by friction, which is equal to force times distance. Does that make sense to you guys? All right, cool.